To start my today's session, and my today's session will be on a new topic. It's not new, it is connected to linear programming problem. It is connected to linear programming problem. You can say that it is a special case I am considering right now. A special case, and that special case is called assignment problem. This particular problem is very interesting, and you will get to see that assignment techniques are often used in airlines. Okay, when they try to connect routes or runways with flights. Okay, I will do one such problem in the class if I get chance. So this linear programming problem, it is also a linear programming problem because assignment problem can be, its mathematical model is exactly similar to the model of linear programming problem. Okay, so the two models are similar. So first of all, I'm going to explain what assignment problem is. Okay, for this I need to draw a table. I need to draw a table which I'm trying to draw over here. Because if I try to diagrammatically represent the situation will be more clear to you. Okay, so I'm trying to draw the table. You also do whatever I'm doing in your copy. Every time if you take screenshot, that is not good. Okay, and so my table is complete, my drawing is complete. Now I'm going to put the row headings and column headings over here. My row headings are as follows. I am going to consider, say for example, n persons. I'm going to consider n persons. On the left hand side, I'm putting their names as 1 to up to small n, and similar, these are persons. Okay, for example, and or you can say, if you don't want to talk about persons, because here, as I told you, that two types of entities are present. One is root and another is flight in this example. So none of these is a person. So writing person over here is actually specializing the thing, situation. So in place of person, you can say entity 1, entity, different types, entity of characteristic 1 of n different types, and here you can write entity of characteristic 2 of n different types. Now, as a special case, I can consider these entities as, say for example, jobs. So I'm going to assign entity 1 to entity 2. Entity 1 or if I say in a more specific way, I'm going to assign the person 1 to any of these n jobs, or on the other hand, I'm going to assign any job, a particular job, to any of these n persons in such a way so that some situation gets optimized. What sort of situation I'm talking about? Okay, let us try to find out. Suppose, for example, I'm just drawing this table to make, from pedagogical point of view, to make you understand what I'm talking about. Suppose, for instance, T11 is the time required by the person to finish the job 1. T12 is the time for person 1 to finish job 2. Okay, and in this manner, T1 n minus 1 is the time required by the person to finish job n minus 1. And similarly, we have T1n. So we can put all the T's in this manner. So let me put it. Okay. Let us put it these things. And in this manner, if I go on, so lastly we'll get and Tnn. All these T's are actually times. So I can represent, I can write here, Tij denotes the time required by the person I, to finish the job J, Okay. But you see, if you carefully observe one thing and carefully observe the situation, you think of your class, of your friends, that your teacher can only assign one person to only one job. This is a kind of restriction over here. The restriction is only one person can be assigned to one job. Only one person can be assigned to one job, and vice versa. Okay, only one person can be assigned to one job and vice versa. So if I'm associating person 1 to job 1, then I cannot associate the person 2 to job 1, and so on. If I'm assigning the person job n to person n, I cannot associate job n to other persons. One person can do only one job at a time, not more than that. That is a kind of restriction. So keeping this in mind, I am writing here, according to this situation, I am writing here 1 dot 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 1 and 1. Okay, that means this represents that one person has been assigned to this particular jobs. And similarly, below the columns, I can write this once. What does that mean? Let me explain. It means that, suppose, for instance, I'm saying that person 1 is eligible to do job 2. So I'm allocating person 1 to job 2. So I'm writing here 1. Now, this person 1 cannot be assigned to other jobs. So I'm putting here 0, 0, and 0. In all other cells, we have zeros. Okay. Similarly, suppose I'm saying that person 2 can be assigned to job n. So I'm writing here 1, and in every other cell, I am putting 0. Suppose I'm saying that person n minus 1 can be assigned job 1. So I'm putting here 1. In every other cell, I'm putting 0. And suppose lastly, I can put 1 over here. I can assign n to n minus 1. And in every other cell, I'm putting 0. So now you take the summation of these pink colored items. If you take the summation of these pink colored items, what will you get? We will get, the total summation will get 1. So you see, let us try to write this out. Okay. So what are these? I'm going to write these restrictions. Let us write this restriction that only one person can be assigned to one job in a mathematical way. Let us write the restriction in a mathematical way. Okay. Now, mathematical way. Now, suppose I'm this T11, T12, T1n minus 1, T1n, all these T's are actually times. Okay, as you have understood, these T's maybe I may not consider T's as times. I can, in place of T, I can consider D as distance also. But in that case, I have to design the situation accordingly. Okay, I cannot say that I cannot retain these row headings and column headings as persons and jobs. If I go for DIG, I cannot say the distance between person one and job job J is DIG. That doesn't have any meaning. So according to the situation, I can consider times, I can consider time, I can consider distance, I can consider loss. These items can be considered, and so on. Okay, I'm going to talk about it later on. Okay, about these items. So first of all, let us try to write the restriction in a mathematical way. Now, if I say if Xij is the allocation when ith person is assigned to job J. Now, carefully observe that one restriction is saying that Xij is equal to 1 if ith person is assigned to job J. Ith person is assigned to job J. Okay, this is one restriction. Okay, and another restriction is that the Xij is equal to 0 if ith person is not assigned to job J. I think you have understood what do I mean by that. I have put this thing in the table. When 1 is assigned to 2, I am putting 1 over here. It is showing that only one person is assigned to job 2, and this person cannot be asked to do other jobs. So therefore, I am saying in general that Xij equals to 1 when ith person is assigned to job J, and Xij is 0 when ith person is not assigned to job J. That is my, I can say that this is my restriction 1. This is my restriction 1. So you take a note of this. What is the other restriction? The other restriction comes from if you take the row summation, Okay, you add all these figures, 0 plus 1 plus dot dot plus 0 0, you get 1. You take all these row sums, you will get 1. Not only this, if you take these column sums, you will get 1. Okay, so I'm going to write it. I'm going to write it in a mathematical way. So restriction 2 goes like this. Restriction 2 says that if I take the summation, okay, I'm writing it explicitly. X11, according to my diagram, X12 plus dot 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 plus X1n, this should be equal to 1. Okay, then X21 plus X22 plus dot 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 plus X2n, this should be equal to 1. And in this manner, if I go, Xn1 plus Xn2 plus dot 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 plus Xnn should be equal to 1. Now, I don't want to write all these things. If I want to compress the mathematical writing, then I can write it in this manner. What is varying over here? The column is varying over here. These are the columns, first column, second column, third column. So I can write, if I represent, if I is the row, I is row and J is column. Okay, so in that case I can say that j runs from 1 to n, xij is equal to 1, and which is true for all I taking the values 1 to up to n. So for if I equal to 1, then you get the first equation. If I equal to 2, you get the second equation. If I equal to n, you get the nth equation. And not only this, similarly, if I add all the columns together, what do I get? I'll get the similar thing. I will get x11 plus x21 plus dot 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 plus x n1, that is equal to 1, x12 plus x22 plus dot 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 plus x n2, that is equal to 1, and in this manner x1n plus x2n plus dot 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 plus x nn, that is equal to 1. If I want to compress the thing, I will write, okay, here you see the rows are varying. This is 1, that is 2, that is n. So I can take summation I goes from 1 to n, x I j, that should be equal to 1 for j running from 1 to up to n. Okay, now you see, when you vary the column, for the first column you get this equation, for the second column you get this equation, for the third column you get this equation. So this set which that I have written, this set is called the restriction 2. Okay, and it is quite obvious that since xij is equal to 1 and xij is 0, these two values can taken by the xij only. So you can definitely say that xij is non-negative. Xij is non-negative. Okay, because xij is non-negative, because xij can take either the value 0 or the value 1. That is the extra condition, but it is quite obvious that it should be non-negative. It cannot be negative. So we have this with us. And now, as I have considered these times, so what do I get now? So suppose I'm going to multiply all these allocations by the times. So 0 will get multiplied by T11, the total time for this cell. 1 gets multiplied by T12 is the total time of that cell. 0 into T1 n minus 1 is the total time of this cell. 0 into Tnn is the total time of this cell. So if I write so, then I will get, and lastly, it is my, I'm going to get, this is not a restriction, this is something else. I'm going to write what is it, but what I'm getting the total time as, in general, I'm getting it as x11 t11 plus x12 t12, and in this manner for every cell, if I go on like this, I get xnn into tnn. Okay, and I can represent this total time by z. Now this total time, I have to, the situation is that the requirement of the on our part is to, the requirement on our part is to allocate these persons to jobs or vice versa in such a manner so that this total time is minimized. This total time is minimized. Okay, so what do I want to do? I want to minimize the total time which I represented by z, and which, according to, if I want to write it in a compressed manner, it will be double summation over I goes from 1 to n, j goes from 1 to n, xij tej. One can also write it as double summation j goes from 1 to n, I goes from 1 to n, xij and tij. It doesn't matter whether you interchange the position of this summation. You can sum all the columns first and then you can take the sums of the rows, and or you can do the reverse. Whatever, you are going to get this. So therefore, what has it become? It is actually becoming the objective function. It is actually becoming the objective function. So ultimately, the mathematical model takes the following form. The mathematical model of this current situation takes the following form. What is the form? Let us try to write it. Write all these things together. So the objective function is minimize capital Z is equal to double summation I goes from 1 to n, j goes from 1 to n, xij, tij, okay, subject to several restrictions. First restriction is I goes from 1 to n, xij, that is equal to 1, where j runs from 1 to n also. That is one restriction. J goes from 1 to n summation xij. What happened? Just a minute. Suddenly my Wacom pen has hanged. Xij is equal to 1. I goes from 1 to up to n. That is another restriction. And I'm writing here. And xij is definitely non-negative with the condition that xij is equal to 1 if I is assigned to j, I'm writing in short, and 0 if I is not assigned to j. So how many parts have we got? You can say that this is part 1, that is objective function. This is part 2, which is a constraint, and this is the part 3, which is non-negative restriction, and this is an extra part according to the situation of the problem. Now think about the mathematical model of the linear programming problem. In linear programming problem also, we have got 3 parts. One part is this, the objective function. Another is constraints and non-negativity restriction. Non-negativity restriction. Okay, so I can say that this particular situation is a special case of linear programming problem. Why special case? It is a special case because why this problem? Okay, let us put this in terms of a question. Why this problem is a special case of LPP? Okay, the first answer is in LPP, the variable can take any value, but here the variables can take value only 0 or 1. Okay, therefore it is a special case. Secondly, now you see that Why did I wrote these terms? What is the meaning of this? Why have I put a star over here? I have considered time in this particular scenario. In place of time, we could have considered distance also. In place of distance, we could have considered loss only, but we cannot consider profit. Okay, profit metrics. Why can't we consider profit metrics? That will be explained to you later on, not now. But if you look at these terms, time, distance, loss, all these things are such quantities which should be minimized. We always want to minimize the time. We always want to minimize the distance. We always want to minimize the loss. Okay, so the second part is that second condition for which this type of problem is called a special case of LPP is because it is a minimization type of LPP in general. Minimization type of linear programming problem. It's a minimization type of linear programming problem. Okay, and therefore in general LPP can be of maximization type or minimization type, but here in this current situation, this is a kind of situation where only minimization type of objective function will be taken into consideration, and therefore we can say that the current situation is a special case of LPP. The current situation, the which I have discussed, is actually called assignment problem. So assignment problem is a special type of minimization type of linear programming problem. So the chapters known is assignment problem because we are assigning things. A minimization type of LPP. Minimization type of LPP. Some other things to be noted down is that some other conditions that has to be taken into consideration is that important points. That you always see that in assignment problem, the number of rows must be equal to the number of columns. Okay, and in certain situation, when it is not, when it is not so, to make these numbers equal, we can introduce dummy rows or dummy columns. As per the requirement of the situation. Okay, these dummy columns and dummy rows, they will just behave like slack and surplus variable, or you can say they will behave like artificial variable to the given linear programming problem. Okay, they will just help us to solve the problem. This is point number one. And point number two to be noted down is that, which is also very important. Now, if someone asks you to, okay, since assignment problem is a special type of linear programming problem, carefully observe that you can ask me that it is quite obvious that this particular problem cannot be solved by graphical method, because graphical method is only suitable for 2 variable problems. At least we can stretch it to 3 variable problem with some pain. But for 4 variables, for 5 variables, this graphical solution becomes invalid. Now there comes simplex method, which you learned. Okay, Simplex method is an algebraic method. It can deal with any number of variables hypothetically. But since assignment problem is a special case of linear programming problem, so hypothetically simplex method can very well work. Okay, by simplex method you can use solve this particular problem. But imagine the situation of the problem solver who has got an assignment problem, and he has been given a mathematical situation, a mathematical model where he is supposed to apply the simplex method. Then how can he do so? Or if you are asked to do so, how can you perform where number of constraint is such large? Total number of constraints here, how many equations here you have got n equations, how many equations here you have got n equations. So here from this only you have got twice n equations. Okay, and this many, and how many variables have you got? In total you have got small n variables. Okay, so solving n variables for n plus and twice n equations is very difficult, or hypothetically is very difficult, and therefore we always avoid to solve linear programming, to solve assignment problem we always avoid to solve assignment problem using simplex. So what sort of methodology we have to use over here? The method used to solve assignment problem, the method used to solve assignment problem is called Hungarian method. So in the next session, I am going to show you how to perform this Hungarian method on the assignment problem. Now, only 2 minutes, 16 seconds is left for this class, and I am asking 32 participants to verify whether they have written their roll numbers in the chat box or not. Okay. And if you want to take the screenshot, then I am just putting the page numbers over here. This is page number 1. This is page number 2. This is page number 3. And this is page number 4. All the points which have been discussed over here, the points that have been discussed over here, all these points you try to remember. I shall upload the video in the YouTube. But you go to the videos, and if you have noted down all the points carefully, then some points which I haven't written but I have spoken. So if you have noted down all the points, you remember that your MCQ type of questions will be asked on the basis of this discussion. Okay, so in the next session we are going to meet. I am stopping this recording right now, and the next session will start after 5 minutes. Okay, 5 minutes break.